Well, luckily the light is very light here. Otherwise, you would see me turn red now. And it's the most special place I've ever held a video conference. I'm actually in a cinema. There was no better place. But yeah, welcome. Good afternoon, hello everyone. Just to make a small introduction, not that it's the most important thing, but that's me, Markus Barmettler. Currently, since 2 years, engaged at Comparis, building up, responsible for the data analytics team and actually building up our data platform. Previously, as already thankfully mentioned by Christina, I was with a similar journey at NZZ, where I was heading the data team, and previously at IBM. But as I said, that's not the most important part. I think we dive into more interesting topics for you. But before we dive into this topic, maybe just a few words about Comparis, in case you don't know. We were founded back in 1996 and actually are celebrating our 25th anniversary this year. So I don't know if we can still talk about the startup, but let's say it's a young startup. We are actually quite known in Switzerland. So the brand is known by 4 out of 5 Swiss people. And a lot of Swiss people regularly use our services. We offer services from health insurance comparison, car insurance comparison. You can search for real estate or a new car. So everything that really helps our consumers to make an informed decisions and implement it safely. Moving on, then what about data at Comparis? At the heart, we have our, let's say, newly developed data analytics platform. We are leveraging that data on, let's say, three downstream use cases. So one is really directly into the product, which I'm going to talk about later a bit. The other one is related to marketing execution, marketing automation. So everything that helps us to personalize our outbound communication with our users. And then last but not least, we want to establish more efficient way of collaborating with other companies and other stakeholders or other partners via, let's say, scalable external data services. What we do not share via those external data services is customer data. That's really restricted only to our environment. Of course, if you request an offer or so, then this kind of data goes over. By the way, my team keeps on making or kidding me. They always say that looks like a coronavirus down there, the external data services. It's actually not. It's supposed to show an API design for external data services. It was actually implemented pre-corona, so no worries about that. Now, really, now that you know about a little bit about myself and hopefully also about Comparis and what we do with data at Comparis to the main topic. So really what I want to share with you a bit is my personal view of how I believe one should establish and scale data products in a company. I have to add a little disclaimer here with regards to scaling products, data products in particular. I've never really been completely in this stage, so I'm really aiming for this. So a lot of what you hear is really something that I currently believe should be the target state, because I think it's the most optimal setup that you can offer a data science to actually scale data products. But fully experienced of what kind of challenges you face, then I unfortunately have not. Just a little disclaimer. But I'm openly sharing my sources of inspiration with you so that you can make up your own mind whether this target state is the right one or not. Now, talking about data science, if we compare it to, let's say, a lot of other functions in a company, I think data science is very different. And especially data products are very different because you iteratively need to explore and learn as you go, explore new features, explore new model, fine tune. You know, it's really an iterative process. that needs a bit of a special setup. Now, but if you think of it, especially in online business, it's actually not that far different from how we are used to design and develop products, from user experience to software engineering to actually iteratively A/B test products and work with it. So considering this similarity and considering that a lot of businesses, especially in the online business world, have, let's say, moved to product teams, dedicated agile product teams, I strongly believe that in order to scale data products, we actually need to ambition a target state where the data science role is directly embedded into agile product teams, so that it can really be as part of the sprint teams and features, ideation and all this, so really taking the ownership on those data products and moving it forward. I also believe that, I know there is a bit of a debate going on there, whether you should separate data feature engineering and allocate it to the data engineers, and then the data scientist is really just doing machine learning, or let's say training the model. I also believe that within those product teams, we might get back to, let's say, a full stack data scientist that owns the whole pipeline. And the reason being, I think being agile in a product team, I really strongly believe that you need to have as little dependencies as possible in order to be able to move forward fast. But what I also believe when I look at this target state is that the overall environment needs to be empowered by let's say, a central data analytics platform and overall governance, so that we don't reinvent the wheel and basic technology within each of those product teams, so that we actually have scalability across the data science function. Now, I added a link down here. I'm strongly inspired by Stitch Fix, and I strongly recommend that you have a look at this homepage. They really made it up nicely and described this target state. Yeah, be cautious. I think it's obviously for recruiting purposes, so they try to attract good people, but the way they describe this target state really touched me, and I can strongly recommend to have a look at it. Now, what do I think we need, or which steps do we need in order to get there? So I think this target state is described, but what do I think what steps do we need to take in order to get there? I tried to come up with those, let's call it maturity levels. So I think there is a preparation phase, an exploration phase, a stabilization phase before you can move on into this target state. And in the following sections, I'm going to describe each of those different maturity levels and what I believe needs to be done in those different steps. First things first, prepare. You also will continue to see those three dimensions, considering stakeholder, organization, and technology. And it's really from a point of view of myself, basically, or someone else that is leading that initiative or leading the transformation, because it's those three areas that you constantly need to manage in order to go through this transformation. So one is the stakeholder dimension, so like your peers in the management or upstream, or also like other product teams, like the outside organization. Then there's the organization, so the data team itself. How do you need to structure your team? What could best help them? What kind of help do you need to provide them? And then, of course, the technology stream. So in this preparation phase, I think it's really necessary it should be a no-brainer, but you should have a data strategy in place. So, what kind of data assets do you have? With what kind of data assets can you work? Are there any legal implications to it? All those questions can be addressed quite early in the process, and if you don't do it in the beginning, that can lead to inefficiencies during the execution. So I think it's important to centrally and early address those questions so that you have them tick the box and can go into execution mode. Secondly, as part of that step, I think it's important to have a data governance board. I think there are different names to this, but we called it data governance board. And really, how does this help the data science team during execution? It's really an escalation path for questions. Those can be as simple like, am I allowed to include the gender attribute for a model or not? Or does this create a bias? Is it ethical correct or not? Or can I work with this data set for this model? Really simple questions that you can address. Second stream or second part, organization. I think you need to specialize your team during that phase. It depends, of course, a bit on the size of your team. But in my particular case at Comparis, but also at NZZ, the existing data team was really more towards this notion of reporting and data warehousing. So we needed to basically specialize the roles around data engineering, platform engineering, more like software engineering mindset to bring into the team. And also during that phase, but again, depending on your team, I personally, I think for smaller teams, it's really valuable to onboard or evaluate and onboard an external partner, because there will be a lot of niche know-how on the way, which you can't just have internally all the time. So having a partner that can actually also provide niche know-how is highly recommended during this phase. So that will provide, let's say, a data team that is specializing on, let's say, this notion of data and business analytics, reporting, analysis, and one part really about data science and data products, but all of it supported by a strong platform engineering and operations team. What's also very important during this first prepare phase, I mean, there is no data products without data. I think it's important to build up your data infrastructure. Personally, I would default to the cloud because I badly burned my fingers with on-premises infrastructures. But of course, there can be different criteria for why, when, and whatever you deploy in the cloud. I personally would always go to the cloud. What's also really important during that phase is to set up especially for online, for digital touchpoints, a data layer, and then actually start streaming that data layer directly to your data analytics platform. The data layer, if you want to know more about, if you want to understand this concept a bit better, I highly recommend you this link that I added down here. It's Snowplow Analytics. It's just one way of doing it, but they have really, from a conceptual point of view, how to structure a data layer, how to create it. They have a lot of interesting material there, so I recommend you to go through it if you want to understand this topic a bit better. They also offer quite a lot of open source libraries for client-side tracking, but also for back-end processing. So yeah, definitely a good starting point. Not saying it's the solution, but definitely from an educational point of view, a rich source of information. Now, once you have set up your let's say data infrastructure, data team, and data is flowing into your environment, I think there comes the exploration phase. Again, split by stakeholder, organization, and technology. Now, what I personally faced is that during this, in the beginning, there is a lot of different, let's say, ideas what AI and ML is and what it can do. So they're either completely moonshot ideas that are too far away, or they're completely unaware. And very seldom they have a really nice point of view that is really nicely fitted. So there needs to be some education. And I think it's worth investing into, we called it AI ML 101 sessions during this phase. Back at NZZ, I think we did personalization workshops, what means personalization and all this. So we aligned the organization. So really a good idea to start involving all the people from the organization in order to come up with a really good backlog of data product ideas. Secondly, organization. You see, I only added here the data scientist onboarding because I think there's nothing worse to onboard a data scientist that needs to go and work somewhere and doesn't have data or access to data. So I personally would highly recommend to do the low-level engineering and data collection before really onboarding data scientists. Otherwise, there's a big risk of them being occupied with, let's say, traditional reporting tasks. And that's definitely not what you hired them for. Something that is actually good to explore in this phase as well is to start decentralizing this data and business analytics roles into the organization. Luckily at Comparis, this was already the case when I started. Now, by doing this, I think you can gather valuable learnings of how this matrix organization for data works with competence teams, what kind of breaking points do you have, what kind of exchange platforms you need to offer, knowledge exchange. So I think there's a lot you can learn, like how to embed this decentralized role into your organization. So this will lead to, this is how it looks at Comparis currently. So we have those core functions which basically data analytics is one, but then across the different business functions, we have dedicated data people, currently mainly focusing on, let's say, more the analytics reporting side, but I think that's a framework that can later be scaled or reused also for the data scientist role once you start embedding it directly into the product teams. On the technology side, I think that's the time then where you start prototyping the data science workbench or MLOps, it's called sometimes. There can be really complex, to be honest. So I think it's really, I recommend to closely team together the data scientist and the data engineer and to iteratively prototype this environment based on actual use cases and MVP in order not to make the whole setup too complex. But what's probably from a establishing and scaling data products perspective, the most important part here is that you early on start or identify, data product. You want to deliver data products as APIs. Now that can, if you have to tackle legacy systems, that are not capable of integrating microservices, then maybe it's time to start somewhere else. But I think for us, I assume this is an online business audience. So I think within online business, it's kind of normal that you integrate via APIs. So it shouldn't be that of a big challenge to integrate personalization or recommend their APIs into your front end technology in order that you can actually deliver this data product directly to your audience. So what did we do at Comparis? So we were working on two initial data products. One was about personalizing our homepage teaser. So this, depending on your, let's say, application that is most relevant to you. So whether it's car insurance or health insurance or real estate market. Behind the scenes, it's a quite simple random forest model that we compute there. The other one was the Comparis used car price prediction. So for every car ad that we show on our platform, we also calculate a market price and then compare the offered price to this market price in order to give our users an idea of how fair is this price that they are currently looking at for the ad. Now, with regards to your first data products, I think it's really important to have on the one hand side something that's already creating a lot of value to the business, but at the same time, because you're still building up the back end, not adding too much complexity into your back end. So if you, for example, have some really complex recommender that needs a lot of back-end computation, it might be a bit a longer path. So in our case, we were really lucky with those two data products because from a back-end engineering perspective, they're quite lightweight, but they were already offering value to our business. And at the same time, we had some MVP to learn with our technology department on how, or our product teams, how can we integrate APIs directly into our client experience. There is actually a really nice article down here, which I linked, Getting AI to Scale. It has a nice comparison of, let's say, situations in a project where your aspired data product is either too simple or too complex, and I think you want to hit that middle ground so that you can actually provide value fast, but still have enough time and reduced complexity for the backend. Now, after this explore phase, you have your first data products live. You raise some awareness in the organization. It's an established architecture on how to integrate, but really there, I think, is the stabilize phase, and you see it actually in brackets because I was unsure whether it's really necessary to add this phase explicitly, but from a change management perspective, I really think something important is happening here. Because so far you were in fast iterations and MVP modus and deliver a beta product fast, and I don't know how disciplined that other teams are working, but especially for the projects that I work, you actually add up a lot of technical debt during this phase. So it's maybe a good time to first reduce those tech debts a bit before you scale it out across other product teams. And also what I realized in the past, that during this phase, it might also be a bit the time of fluctuations in the team. Because, building something up fast, going for the first product is quite a bit different than, taking something, run it, operate it, and scale it out. There might be different people in the team that liked very much the first part, the innovator part, but maybe not so much the second part. Where on the other hand, there can also be teams that really try to come into it, or people that come into a team when something there is established and they don't need to reinvent everything, so they can be more productive. So I think they're both type of people. But from a change management perspective, I really think in this phase, something important happens that needs to be considered and managed before you then really move on to the next phase, which I think is this scale phase, which I already described. As I already noted in the beginning, as a disclaimer, I never been fully in that operating model. Just scratched it with, let's say, a first MVP in another team. But from all what I have seen so far, really that's the target state that I'm aiming for. And but I learn every day, every month, every year. So maybe this changes in the future, but for the moment, I think this is where I think data products can evolve the best. And if you want to challenge my source for inspiration, that's linked down here again from Stitch Fix. Highly recommended source if you want to go through and have a look at your own. So what's then the CDO? So I'm based, that stands for Chief Data Analytics Officer. I'm not to give a lot about titles, but I was leading this transformation, and I'm still leading this transformation. So what's really my role in all of this? I think it's a lot of communication on the target state, where you want to go, expectation management, because as I said already in the beginning, so they're either really moonshot ideas or too simple ideas. I think it's a challenge to find really this middle ground of complexity of data products. And then really, just listen carefully to the teams, to the people, what they need, what kind of obstacles that they have, because I think it's your role to help them succeed and move away obstacle out of their way. And of course, networking, collaboration across departments, because you're really aiming for a decentralized organization. I always tell my team, or actually not only my team, but my job is to build bridges, not walls. I too often saw like protecting teams and building walls, and I don't think that's the modern way of working. It's all about collaboration, cross-functional teams. But I think that's not really new to you, I assume. But the true fact remains actually, because you ambition this decentralized setup. From day one, you actually work for a target state, which makes you redundant at the end because it becomes self-operating and autonomy in those different product teams. And that's actually it. And we can move to Q&A if there are.
Thank you, Markus. Thank you for sharing your experiences and your vision for the target state. So let's talk a bit about timing. So you've kicked off actually the presentation by showing the target picture where data scientists are embedded in the product teams. When do you think is the right time to switch then from an initial central data team to this decentralized model? Like how big does the team need to be, and how big should still the central infrastructure team remain, or in any other maybe criteria that you think of when is the right time, besides what you've just also shared with us?
Yeah, I don't think if there is one answer, but there are some considerations when finding out if it's the right time. I think it's about the maturity level of the technical infrastructure on one hand side and the maturity level of the product teams, because maybe you have somewhere a product manager, product owner that has a good understanding of AI, ML and is educated, so maybe that's a better place to already start adding like a machine learning engineer or a data scientist role to the team. On the other hand, I think it's really also the maturity of the technical infrastructure. And really on my end, originally there was a data engineering team, but I renamed it to platform engineering team. And I think there, in order to be, also depends a bit on the size, but I think a minimum of the organization, but the minimum size of people that you need to have in this team, I think is 3 or even 4. So that you're really capable of also backup solutions and pair programming, this joint collaboration. I don't know if that fully answered your question, but really I would watch out for teams that have a certain maturity level and interest also to invest in this notion of machine learning and data science, and then trying to make a first MVP with them. Trying out this new organization. I don't think it's necessary to roll out all at once, but start with a team here, gather some learning, go to the next team. That's how I would do it, except you have a large pool from different product teams, then of course you need to change your decentralization strategy.
Thank you for your input. We also have a question from the audience, and I think it's a good overall topic to talk about, which is roles. So the question from the audience is like, what is the difference between the full stack engineer you were mentioning and the full stack data scientist you were mentioning and the normal data scientist, in your opinion?
So it was also a learning of myself. Historically, we had those let's say large notebooks where you pull in data, you do feature engineering, and then you have this training data set, and then you start training the model and validating the model and everything. But then really, I had it in the past that then this notebook was passed over to the, let's say, infrastructure team, like, hey, this goes onto your cluster. And then there was the answer like, hey, no, this code, no way, this gets on my cluster. Especially the data at feature engineering part was purely optimized. So that is when I changed a bit my mind and thought, okay, why not separate feature engineering from data science? So really have a data engineer pulling data, aggregating data, managing feature stores, so all this kind of thing. And then having the data scientist really just pulling in the features and start model training. Of course, this is more related to traditional type of machine learning than it is like more neural network-based models. so I was a long time with the separation of feature engineering goes to data engineers and model building goes to the data scientist. But then I was a bit inspired also by this article from Stitch Fix. And there they gave this input like it creates a dependency which is unhealthy for agile teams. Maybe this problem is not there because maybe there's just next side a data engineer, so you can really good work together. But I think when I talk about full stack, it's about having being able to work independently. So in the morning you have an idea like, hey, I could try out this feature. You open your notebook, you put in this feature, you retrain the model, and you deploy it without any friction points to any other team or function.
So as I understand it, like being able to interact with the cloud, for example, right? And being able to simply extend your feature set if the data is available then in the data lake.
Yes.
And how long on the other side do you think it should go, like all the way to deploying the API or providing a package that can then be implemented in the application?
Ideally, that's actually we just now have this discussion at Comparis who owns the API. I think there needs there needs to be some low-level support of tooling available, but ideally, the data scientist could launch a new version of the API independently because maybe it needs to be embedded into an A/B test. They need to measure it. But I haven't thought this through to the end, to be honest. So, yeah.
It's so much also it's like dependent on who you have on the team and where you're starting from, right? So maybe another question to the roles, like looking at the job market, we see now a lot of new other data related roles appearing, like data product owner, data product manager. What's your take on those roles? Do you have them in your team? How do you use them?
Yeah, we had a data product owner, but just because it was such a nice fit to the person, unfortunately, that person is not on the team anymore. She moved on with her career, and I highly congratulate. But I'm a big fan of this combination of data science, data product with the product management world, because I think both areas have a lot. I believe in the synthesis on both worlds. So how we developed product, with user experience design, feedback loop, and on all those kind of how this is approached, user-centered. I think if we are able to bring in a lot of this thinking into the data product role, I think that can be a really promising role in the future. Whether that is a product manager who's scaling up on AI techniques, or it's a growth path for a data scientist, or it doesn't need to be a growth path, but an extension. I'm open, yeah. But I really think there is a spot in the middle for this notion of data product management or data product owner that can add a lot of value in the future.